time now. What we are going to do now is going to move on to the next session. And the next session that we have is SODA Open Data Framework Update. Uh, SODA is organized by SODA Foundation. SODACON is organized by SODA Foundation. And you must have got a good picture of what the foundation is from Stephen's keynote and from Larry's discussion about the ecosystem. But what about the projects? What are the key features and use cases? What about the current releases? Let's hear about the SODA project's architecture, key features, and the roadmap and release roadmap of the current release as well. On the screens now are Ashit Kumar, Najmuddin CT, SODA maintainers, Noelle McLaughlin of GB Technologies, and Saurabh Gupta of Click2Cloud. Over to you, Ashit.
Hey, hi everyone. Good evening, good afternoon, good morning. And so today we'll talk about the SODA Open Data Network Framework updates. And let's start with this. Can you see my screen? I'll just a minute.
Yes.
Okay, so the slides are visible?
Not yet opened.
Just a minute. Is it visible now? The slides are?
Yes, Ajit. Yes.
Yeah. Okay. So hi everyone. So today we'll be presenting about the SODA Open Data Framework updates. What are the key features, releases, and what are the landscape, what we are thinking. So stay tuned for all. So today and tomorrow we'll have multiple sessions on the what SODA projects are, what are the future projects that we are thinking of, what are the vision that we are going to engage. So these and we will have some demos also, so you can check that. To that, I'm Ashit Kumar, and with me is Noelle McLaughlin and Najmuddin and Saurabh Gupta. So maybe Noelle, you can just quickly, everyone quickly introduce, and then we'll move on to the slides.
Hi, I'm Noelle McLaughlin. I work with GB Technologies. I'm a main contributor to Solve Stack Formulas community, infrastructure as code, and I'm with the SODA Foundation about 3 years. I mainly work in the area of deployment.
Yeah, Najmu.
Thank you.
Yeah, hello everyone. Myself Najmuddin. I work for SODA Foundation project for around the last 2 years. I am a maintainer of SODA Foundation project. Currently, I'm looking into SODA Foundation project called Delphin. Yeah.
Yeah, over to you, Saurabh.
Hello everyone. Good morning, good afternoon, good evening, whatever it is there. So I am Saurabh Gupta, and I have been working in Click2Cloud as a software developer, and I have contributed to SODA since last 1 year. So that's all. Thank you.
Hey, hi. Thanks, Noelle, Najju, and Saurabh. So I am Ashit Kumar, and I am one of the maintainer of SODA projects. So let's quickly move on. And okay, so here is the agenda that we'll be quickly covering the major core projects of SODA, and then the experience part, SODA installer we have, and then we'll be talking about some of the use case and end user adoptions. And yeah, we'll close up with the roadmaps that we have, what exactly we are thinking and what we are going to do. The release, you might have heard from in the keynotes from Stephen and other keynote speakers, the release roadmaps and what we are doing. So quickly moving to the framework. So whenever we are talking like SODA Foundation, the question comes like, what exactly the framework, what exactly you guys are doing? So what we are trying to do is, SODA is a single data framework which connects disparate solutions, and it is a seamless end-to-end solution that you can see. So over the right, if you see the picture, we have the solutions which can span across the edge, core, and cloud. And so in between, you see the blue boxes where we have different projects. So you can see data protection, data governance, data analytics. So these all are like the future projects that we are thinking, and you will hear more about this in upcoming sessions today and tomorrow. And even we are trying to create a single data store for block, file, object. And then on the south side, you can see the different enterprise solutions for storage. So this is how we are trying to connect. So it's like connecting your northbound to the southbound through the projects inside SODA. So northbound, you can have different compute platforms, big data platforms, or be it the AI ML or any platform. So we just want to connect that to the storage behind on the side, south side. What the value proposition? You can see that data mobility, standardization, operability that we are sorry, that we are talking in the panel discussion also. And the key highlight will be the why SODA Foundation. So the key highlights will be like open source, standardization, ecosystems that we are creating, ecosystem for hardware, software, different solution services. And again, you will hear about the certification and different things. So it's an open source community where we are trying all this. And all these solutions, as you can see, that we are trying to be optimize it, make it autonomous and highly scalable. Okay, so when we talk about projects, we have different projects. You can go on the GitHub and find out these different projects. SODA Foundation has multiple projects, be it for on-prem, for cloud, or for your installer, even for anomaly detection, orchestration, everything we have some solutions. So you can check out these projects. Okay, so as we have been talking for the SODA Foundation, what exactly we are trying to achieve is like you can see this slide from the storage perspective or the data management perspective. You can see that we want to create one data store, right? So why one data store? You can see that the storage and everything like the data management platforms are fragmented. So we want to create a unified view. So on over the top, you can see the unified data management API, and there is a controller, which is nothing but like a metadata or a bookkeeping, where you can create some policies, you can create the metadata management and all. And then we have the storage. We have been like there are different file storage, block, object, and for them we can connect to the different storage on the south side. That is the bottom that you see. And this storage, be it on the edge, core, or cloud. So a single platform, one data store that we want to create. Okay, so the journey of SODA project. So we started something from core on-prem, the solution that we initially, so you might have heard that from the history that OpenSDS has emerged to SODA Foundation or has been transformed into SODA Foundation. So previously we used to have this on-prem solution called Hotpot, which used to be like a API controller doc. And now we are increasing the, when we are talking about the end user use cases, we are talking about the storage resource management and where the Delphin came into picture, the storage provisioning and all. So we'll hear more about that from Naju. Then is SODA MultiCloud. Obviously, the MultiCloud is a multi-cloud and hybrid cloud. That is one of the key things that we need to tackle right now for the data management. Then we have some solutions for edge. So people were asking what applications or what solutions SODA has for edge. So we have some projects, example projects, POCs that we have done with the Cubage. You will hear more about this in tomorrow's session by Sanil and Kiran. And again, for all these projects, you need to have some experience. So for that, we have dashboard project and installer. Noelle will talk about that, what our vision is, how we are trying to make a very scalable and unified installer solution. And then again, the documentation and some of the experimental projects as we are talking about, orchestration, anomaly detection and all. So those are there. Okay, so I won't go very much deep into this architecture or the diagram that you see. There are lots of boxes and text. So we have been talking about on-prem, cloud and all, right? So we have different solutions. If you see, first one is the on-prem data management across heterogeneous storage. So that is where we have solutions like SODA Foundation Doc solution is there, as well as we have SODA infrastructure management, which we call as Delphin. Naju will talk about that. So these are some of the on-prem heterogeneous storage management solutions we have. Then we have some on the right side, if you see the multi-cloud block, we have storage monitoring across. For file, block, and object storage, we have the storage data management solution over here. again, I'll go more deep into this multi-cloud solution, how we are doing the file services, block services, and the cloud services, different cloud vendor support and all. So yeah, quickly moving, like where we are from the on-prem perspective, if you see, we have a unified API. That unified API is mostly for the file and block management. So for that, we have the SODA API project. And then on the south side, if you see the heterogeneous storage support, for that we have SODA doc project. And that doc project currently supports, so it's basically, as the name suggests, like it's a doc where multiple drivers can come and attach to it. And we have different storage drivers supported as of now, like for example, Ceph, DRBD solutions for the replication, the host-based replication and all that we do. So that is the DR solutions we provide. Then we have drivers for the Fujitsu storage, HP Nimble storage, Huawei, IBM Spectrum Scale. We have supported the block, that is like mostly the software-defined storage from IBM. And then we support this NetApp, SAN, and NAS. We'll talk about why these drivers were supported. There were some use cases that came from the end users. Then Qtech, we have native LVM support, Chihuahua FS, then OpenStack, Manila, and Cinder for the file and block that we have. And if you see, these are the distributed metadata management that is controlled by the controller projects. So SODA has got another project called SODA Controller. So that project is basically the, so you can have a HS solution of SODA in, for example, for the DR. Now for that, you need to manage your metadata, which can manage the metadata across your nodes, which can manage your metadata for the API to doc connection, right? Your replication management, your DR management, everything is managed by that metadata. And eventually this will be expanded to the multi-cloud also. So you will have a unified controller which can manage your data on-prem and to the cloud. Yeah, so I'll quickly walk you through the SODA multi-cloud project. So this is one of the project that is very widely, like from the end users, we have seen the use cases. The pain point on the left side of this middle arrow, if you see, so of this arrow, the left side, you can see that there are different cloud providers, be it AWS, Amazon, GCP, Alibaba, Huawei Cloud, or anything. So what a admin needs to do is that they will have to invoke different set of APIs that will connect to different clouds. So cloud one, say AWS, cloud two, Azure. So they will have different APIs to connect to this. So this becomes a pain point. So as the number of cloud providers they support, so as the there are different reports, Forrester report or the Gartner reports. So those reports says that multi-cloud, most of the organizations will be moving to the multi-cloud architecture or the scenario of the multi-cloud. So over there, different APIs, say suppose this cloud one goes for say cloud N, and that is say 30 or 40 or whatever odd number you can pick. So now what will happen? They will have different APIs. This is one of the pain points. And that is where SODA one data framework or one data management solution comes into picture. So SODA provides a unified API. That unified API and under the hood, that it can connect to different clouds, but the end user, the admin or the end user over here don't need to care about the different set of APIs from different cloud vendors. They will invoke a single API. Say I say /XYZ. That API remains same for cloud one, cloud two, and cloud three. And XYZ is nothing but say move my object from one bucket to another bucket. So that remains the same. So that is where the unified API SODA multi-cloud defines. Yeah, so this is overall architecture of the SODA multi-cloud project. You can see that we have REST-based interface, we have global configuration, we have policy-based data management, so data migration and data lifecycle management. These are two important aspects. So while continuing for the demo, you can see the Greenland demo. You can see the data migration and lifecycle demo. Then we support, as we have, I think Louis has talked about, that EG, Ceph, and Gelato has integrated. So that integration, then we support the Ceph object storage also. And we are not constrained to the object storage only, where we support the S3 compatible APIs. we are expanding it to the file and block-based storage also. And right now we have started supporting the file and block-based, where we can check the different use cases like LTR or maybe cloud bursting and all, which can be solved using the SODA MultiCloud file-based solution or the block-based solution. So that is where, and again, we have been talking about this cold storage, right? So archival and retrieval, archival into the cold storage, that is something SODA MultiCloud has ventured into. Like we are defining some of the issues and tasks. And so over there, you can find the SODA cold storage support also, archival and retrieval based upon the clouds. So this is completely like cloud-based archival. Yeah, and security we have been supporting. So security is one of the major aspects. Whenever you see any multi-cloud solutions, security will come into picture. So there we are enhancing, we are supporting some of the SSC, KMS and all, and we are enhancing it to different clouds. But for the end users, for the unified APIs, we have some keystone-based security. So that we do, and we will be enhancing that. Yeah, so I'll quickly move for the time. Yeah, so, okay. So just to tell about the other projects, you will see some of the demo for say CSI and all. So which Naju will talk about. Yeah, Naju, over to you.
Yes, thanks, Ashit. Hello, everyone. So I will introduce to you about some projects. One is NBP. So NBP stands for Northbound Plugin. So as Ashit mentioned, Northbound is the place. The Northbound platforms are the place the compute platforms utilizes or consume the data, right? This is a platform which uses the data or generate the data. Now, we need to integrate the storage to these platforms. What are these platforms? These platforms can be Kubernetes, VMware, OpenStack, or even application platforms like Big Data, Hadoop, Oracle database, right? So to these platforms, we need to integrate the storage. So northbound plugins are the SODA provided plugins to these platforms so that the SODA framework can be integrated with that platform, right? So from SODA, we have basically two plugins available now. One is CSI plugin, another one is VMware plugin. First, I will talk about CSI plugin. CSI stands for Container Storage Integration, and this is a standard for integrating or exposing block and file storage to containerized workloads, right? Containerized workloads like Kubernetes, Mesos, and all. So SODA provides a CSI plugin. So SODA provides a CSI plugin means SODA has an implementation which compliant to the CSI standard. That means it implements the CSI APIs like create PVC, attach PVC. So that kind of implementations are there from SODA, and this plugin can be used in a CSI compliant containerized platform, containerized orchestration platform, so that this the SODA framework and platform integration can be done. Now, as you know, what SODA core does is SODA is a framework or an abstract layer on top of your heterogeneous storage devices, right? It can be a different vendor storage devices in the southbound, and SODA plays a role on above that. SODA provides a unified API for the northbound platforms. Now, as you see, the plugins, so the CSI plugin talks with the platform as well as SODA API. So it is kind of an adapter which takes the platform request and convert that into SODA API to provision the storage. So this is the CSI plugin what SODA is providing. Now, so basically, every vendor has to provide the CSI driver to integrate with the cloud orchestration platforms. Nowadays, every vendor is providing CSI drivers. SODA is looking an option to see how we can utilize the vendor provided CSI drivers as it is in SODA. So basically, SODA is looking for two providers, two solutions. One is through CSI plugin, which is provided by SODA, and another one is CSI plug and play, we call it, which can be like reuse the CSI drivers where vendor is providing. We have some demos regarding that, and yeah, so this part of the NBP project, the CSI plugin part of it is developed in Golang, and which is available in open source. This is an information for developers, whoever is would like to contribute to CSI plugin, right? They can see that in the NBP project. Now I'm moving to VMware plugins. So VMware is another platform, another major famous platform in the data center, right? So VMware, if you see the infrastructure of VMware, you can see ESX servers, you can see VMs, and you will see management softwares like vCenter Server, vSphere, vRealize Orchestrator. So there are, this all consists a VMware infrastructure, right? So to integrate to VMware storage into VMware infrastructure, VMware provides libraries and SDKs for the storage vendors to implement that. So as I said in CSI driver, the storage vendors will provide a mechanism to integrate with the VMware. Similarly, SODA is providing a unified way of integrating SODA framework with VMware. So VMware has different mechanism to integrate with the VMware platforms, like you can integrate into block storage as data store or a NFS data store, or you can also integrate as a virtual volume. They call it VASA provider, right? So as of now, SODA has done a block storage integration with VMware by providing a VMware plugin. So this VMware plugins, two kind of plugins are available now. One is called an NGC plugin, next generation client plugin, which is a vSphere client plugin, which can be used in vSphere web client and vSphere Flex client. So by using this plugin, the VMware platform, the VMware management platform, will be able to see the interfaces, the user interfaces to integrate SODA storage into VMware, right? So similar to CSI plugin, what this plugin does is that this plugin has some implementation to convert the VMware storage integration request to SODA APIs. So the same thing happens. So there are two plugins available now, NGC and VRO. VRO is for the vRealize orchestration, and NGC is for vCenter plugin. So yeah, so this project is also in NBP project, which is a Java based project. Yeah, so that is pretty much about the NBP project. Now I am moving to another project, which is called Delphin. In our previous panel discussion, we heard that they're talking about the storage, the data silos, and the challenges in managing that. So one example which Ravi and Tadagat pointed out was a single digital marketing solution itself is looking for 20 different technologies, right? So as you know, the data center is growing rapidly and the multi-vendor solutions are there, right? So there are wide range of 100 wide range of devices available in the data center. The main pain point of a data center administrator or a storage administrator is to monitor and manage this heterogeneous infrastructure. So SODA is coming up with a solution for monitoring and managing heterogeneous infrastructure. So this is a recent SODA Foundation project. This is for the intelligent storage monitoring and management, and it is called Delphin, which is again a unified heterogeneous resource performance and alert management, right? So using Delphin project, what Delphin project provides is a mechanism to configure your device for monitoring. So the user can configure their device for monitoring. Now, once the device is configured for monitoring, Delphin provides metadata about the resources. Delphin provides performance data about the devices. Delphin also provides real-time alerts from the devices. So this framework, if you see, at the bottom side, you can see there are drivers. These drivers collect metadata from the storage infrastructure. And we have a task manager. This task manager create task for collecting data, right? And we have alert manager. Alert manager get the alert from the storage infrastructure and provides to the clients. And this is a scalable architecture where you can add more drivers to this to support management of different devices. Say, for example, if you want to support EMC VMAX, we have an EMC VMAX driver available for monitoring and managing. Similarly, HP3 PAR. So this is a scalable architecture where we can add more drivers to support those devices. Similarly, in the other side, the northbound side, we have exporters. So the data which is consumed is probably for in different clients. Like one could be Prometheus, one could be some other platform like Nagios or Zabbix or any other monitoring platforms, right? So we have a mechanism to provide exporters for these platforms. So the collected data is pushed through the exporters to the clients which who are looking for this data. Yeah, so this is about the Delphin project, and Delphin project is a project which is actively developed now in the SODA Foundation, and which is basically a Python-based project. So those who are interested, you can have a look into the Delphin project as well. With that, I think we can move to SODA experience side.
Right. Yeah. Thanks, Naju. So
Yeah.
basically, we have seen different projects till now, on-premise and cloud projects. Now we need a installer for that. So Noelle can walk us through like how we are doing it for SODA experience. Yeah, Noelle, over to you.
Hi everyone. So I just have 3 slides here for the SODA experience installer. So my background is in the SODA project. I joined about 3 years ago because I've done a lot of work in SolStack formulas. That's infrastructure as code. And what SolStack formulas we're trying to do is it's very similar to Ansible Galaxy. It's a community of people who are trying to install CNCF, you know, the cloud native landscape components, in a consistent manner and in a very scalable manner as well, that we can scale out, we can deploy to distributed systems. So I think you've all heard of Ansible. Some of you might have heard of Salt. So I work with Salt, but they're very similar, but they're both Python-based. What a lot of these installers, and that's Ansible, SolStack, Kubernetes, KubeEdge, Helm, which is package manager. They need artifacts to describe what they're trying to install. So the commonality across that, and in trying to design this installer for SODA and redesign it, we need to look for patterns. So one pattern definitely we can see across all installers is YAML is used to model what we're trying to do. So just going through this slide, for the SODA installer, really, we have a requirement for a single installer, and even installer is kind of a bad name from an end user's point of view, because we want to do more than install. We want to install, upgrade, reinstall, clean, and roll back. If an upgrade fails, we want to roll back. So the challenge for installers is there's a fragmentation. And I suppose in projects like Soda Foundation, OpenStack, UpInnoFee, there can be a lack of interest in installers, in that when the project starts, we get about 5 installers. And then over time, the projects, we get 4 installers, 3 installers, 2 installers. And I think actually last year, the UpInnoFee project, which is kind of similar to SODA, but it's a different domain, telecoms, they had no installer, So it can be a problem. So what we use at the moment, really, we're using Ansible as the main infrastructure as code in SODA. I wrote a Salt installer. I just looked at what we were doing in Ansible, and I done the same in Salt. And again, I noticed these patterns that Ansible and Salt, they both consume a lot of YAML. So I think in a new installer, and I'm doing a proposal at the moment, which the architecture work group will look at, is to try and define a kind of model, do a model-driven installer for SODA, that each component in SODA has a simple YAML model saying, hey, this is what I am, this is my capability installed, like what version, where do I get my software? And what you will find in the cloud native landscape is that a lot of these projects, they deliver one artifact, which is very, very common, which is an archive file. It's a tarball. This is the kind of standard in GitHub. It's kind of semantic release. So I think what we can do is in this YAML file, we will just probably be dealing with a couple of different formats. One is an archive file. Maybe another one might be a native Linux package. Kubernetes deals with its own kind of Helm or customize. It's really to look at a model-driven installer. That's what we're looking at the moment in the architecture work group, and work is just starting on that. There's a PR gone in this month, just to discuss how we can do a brand new installer. So in orchestration area, I'm going to raise a PR to introduce Apache Airflow in that for workflow orchestration. There's some synergy. It's Python based as well. It's a fragmentation from installer, and how to integrate SODA with the users, and how to integrate all these cloud native computing. You saw the landscape where there's hundreds of components. How can we deal with those in a consistent way in an installer? So we're going to redesign the SODA experience. Probably not this Hawaii release, which is upcoming, but the release after, in April. We will try and introduce definitely a consistent way of installing across the entire SODA project. And also that way of installing may also need to consume a cloud native products like Kubernetes and Prometheus and Grafana and all these different products. We will try and handle those in a consistent way. Just have a YAML model, a YAML file for each one. Just a very, very loose model describing what is the capabilities of this. What is this thing? What is the capabilities of this thing? What do I do to install it? Installing it on Linux there's a lot of standards, like you install software in opt, and there's something called a file system hierarchy standard. It describes to you when you install software on Linux what it should look like. So we'll focus on install, reinstall, and clean down. Try and adopt a model-driven approach to that. And then, because we're adopting a model-driven approach, we can try and tackle the hard user cases, which is upgrades of the SODA stack and rollback. Because we're a storage project, we should be able to do a snapshot before we do the upgrades and possibly rollback. So models, yeah, component fragment model. What that means really is that we could request in SODA that every component writes their own installer. That's definitely an option. But again, the patterns kind of tell us that, all these components, they're kind of doing the same thing, install and do some pre-checks, pull down, retrieve some software, install that software. So I think if we can handle those patterns in a central SODA installer project, then we can just ask components, can you just please deliver a model, a YAML file, which describes your capabilities to be used in this installer. And then we can ask Cloud Native Foundation for this, landscape for this, but they probably won't do that. But that's okay, we can do it because we understand this YAML model, it'll be a standard model, and we can just describe, oh, this is Kubernetes, and this is how to install Kubernetes, and this is the version we want, and this is where to get the software. And the installer will just consume all these YAML files, parse through them using some mechanisms, some patterns that we use a lot in infrastructure as code, and deploy the system using Ansible, Salt, or Kubernetes. Next slide, please. So I went through the backlog of this current SODA installer, and I just went through all the tickets. There was about 40, 50 issues open, just to look at technical debt. And some of the technical debt is very standard, not just in SODA Foundation project, but all across open source. That, open source projects, we need example user cases. What are the example user cases do you want me to prove to you that SODA can make an impact in your company? We also wanted a single command to install a SODA, like SODA deploy, SODA redeploy, SODA, a bit like, we can look at kind of like important projects like Minikube and kubectl to see how they handle installs and upgrades and redeploys, and try and look for simplicity. The SODA orchestration, yeah. So these are issues that people opened. Some people want example user cases, a single command for install, orchestration, which really is that's really talking about, we need SODA upgrade paths. Customers who take SODA, people who take SODA, they don't want to initial install all the time, every time there's a new release. They would like to be able to upgrade from the last SODA release to the next SODA release. So I think that's something we need to bring in, do it in a very simple way, model driven, and also plug that into continuous integration, continuous deployment, so that we can run through the whole cycle and make sure the example user cases are being tested in continuous integration. So people want us to keep up to date with latest versions of operating systems, a UI as well, but we need to solve the problem with the kind of command line first before we introduce the UI. And the UI should be really more a kind of a visual view into it. And the rest of them there, and again, some of them repeat SODA upgrade and reinstall with no data loss. Next slide, my last one. So I think the SODA installer roadmap really is the goal. My goal really is to have a model-driven deployment, and the model will be defined in YAML. It'll be very standard YAML, because YAML is a very it's very universal, simple data renderer. It's widely known. It's widely used in Ansible, Salt, Kubernetes, Helm. Everyone understands YAML. So each CNCF component, which is like Kubernetes, Prometheus, Grafana, they have their own installers. We will look to see if we can reuse that. We can get those installers from Ansible Galaxy and SaltStack formulas. I'm a core maintainer of that, so I can guarantee that any CNCF component that we use in SODA or want to use in SODA will have a downstream installer in SaltStack. Each component should have its own CI, and that means that sometimes we need to, as open source people, we need to raise a ticket on other projects to say, we want to use your project, but you don't do a CI. Can you please start a CI? So it's try not to do all the work ourselves in our project, but offload the work to different communities. Each project should have its own installer, possibly, or maybe its own model, definitely. And the installer really will take all these model fragments, merge them into one common deployment model, and deploy that model onto the system. This is a standard kind of practice in deployment management. And yeah, the technologies we will use really, and you can talk to me about this to see what we're thinking about. YAML for the model, Jinja 2, which is just a rendering language which can take a model template and dynamically create a dynamic YAML from that. QLang is really about validation, constraints, data constraints is that don't deploy this component and this component in the same cloud, you know, or don't use this version, or don't try and upgrade from this version, just to kind of, you know, bring a bit more intelligence into the data YAML, that there's certain things we don't want to do. And maybe use, we're using Helm at the moment, maybe start looking into Customize, which is merged into Kubernetes kubectl. So I think with those 4 technologies, YAML, Jinja 2, QLang, and Customize, we can use those all together and start building a really powerful installer. And the automation, once we have a very good model, we can feed those models into Ansible or SaltStack, or maybe even Airflow and StackStorm as well for the orchestration. And we need to look as well, see what other groups are doing to see, can we share our ideas? Because an installer is an installer, and some of the stuff that we're doing in install, like, you know, take an artifact, download the software, install it, it's common across different projects. So is there other people who need this as well? Thank you.
Hey, thanks, Noelle. So that sounds to be a very scalable approach for the installer, and hopefully we'll consider the HA part of the installer also in this model. Yeah, thanks, Noelle. So quickly moving, like we talked about different projects, and these all projects, it's not like these projects are working in silos. So these are all the use cases that are coming from the end users. We are trying to create different solutions for that, be it the heterogeneous storage monitoring solution, the on-premise solution, multi-cloud data management, heterogeneous object storage management on-prem, or maybe in future to hybrid cloud or public cloud. Then workflow-based orchestration and automation, intelligent storage monitoring for on-prem, hybrid cloud, and edge. So these all are different use cases that we have got from our end users or partners, and some of the suggestions from the community that has come. And again, over the 2 days, you might be hearing all these use cases here and there from different people in the SODACON. And yeah, so there are different supporters where we are doing some trials and adoptions, be it Entity, Yahoo Japan, Huawei, Toyota, or Click to Cloud. So there are different solutions. So can we have a unified platform, or can I manage my file block, everything on a single platform? So one of the use cases that, or one of the trials that we have done with the product of Click to Cloud. So I'll hand it over to Saurav to tell something about that and put a highlight. And yeah, so when we see some of the demos today also, we'll see the use cases that has been adopted or said by trials done by Entity, Yahoo Japan, and all. So yeah, over to you, Saurav. You can quickly tell about what exactly and how the use cases were adopted.
Yeah, thank you, Ashit. So today I'll be discussing about how SODA multi-cloud helped CloudBrain in solving its problem and what problem we had. So actually many of our CloudBrain users were using storage services of multiple cloud vendors. So there was a requirement of a unified platform from where we could access the object storage services. So this is where SODA multi-cloud comes into the picture. Like SODA multi-cloud integration helped us to use it, multiple cloud vendors from a single platform. So what does SODA multi-cloud has, or what has multi-cloud provided us is here. It has provided us with object operation and management, where you can upload object in multi-part object, or you can upload the object in multiple, you can download the object, delete the object. And whenever we are talking about object storage, it is very important to use it optimistically, as it can cost you with a huge amount if you don't so there they have a feature of object lifecycle management, which is very important. So here you can perform in cloud lifecycle transition or cross cloud lifecycle transition. So this I'll be discussing in the next slide. And they also have provided us with a super cool feature, which is cross cloud migration and scheduled migration. So I'll be discussing lifecycle in the next slide. So Ashit, can you please?
Yes.
So basically, what is lifecycle management and why it is important for the users? Like each and every cloud provider where we store our objects, they recommend us to store the object in proper storage classes, or else it can cost you with a huge amount. So it is recommended to store the frequent used data in tier 1, or else you can say the infrequent used data you can store it in tier 99, and the data which you are not using it frequently, or which is important but you'll not get access that data, it is recommended to store it in tier 999. So basically when I am saying tier 1, tier 99, tier 99, so what is it? So it is the generalized storage classes. So as when you go to aws, when you store your object or upload your object into frequently used, so they called it at standard tier. While Azure, when you use Azure, they called it as hot storage. So this is the generalized name which we are using: tier 1, tier 99, tier 1999. So what we are doing is we are automating this process. Like when you put lifecycle policy to any bucket, so all the objects would be moving from one tier to the another according to the user needs to optimize the data. So Akshit, can you change the slide? So how we are going to do this? So I'll give present you. So first of all, we'll have to upload the objects in the bucket. Then we are going to put the lifecycle policy on that bucket. So what is this lifecycle policy? It is like when you upload your object, it will be uploaded to standard tier. So after 30 days, if the user don't have need of that object to be used frequently, he can transfer it to standard I or another storage tier according to his needs. And there is also a delete expiration policy. If the user don't need data after n number of days, so he can also delete that data. So not only this, we have also feature of cross cloud object lifecycle management. So what do we have in that? So there are use cases like our clients use, which is they have to store their important or frequently used data in one cloud bucket, and the another infrequently used data in another cloud bucket. So basically there they can use this cross cloud lifecycle management feature. So this is what we have got in life cycle. And the next which we have got is object migration. So what do we have in object migration is when we come to the word migration, we know we are going to migrate objects from one bucket to the other bucket. So first of all, there is a need of we need to create a bucket. You will upload the objects in one bucket. Then you'll have to set the migration. You can do immediate migration as well as you can have scheduled migration. So this feature you have got, and the other feature which is you can migrate your object across the cloud, and the supported cloud here is AWS, Azure, Huawei, Alibaba, Ceph, IBM, GCP, Yig. So this is what you can do. And another thing is when you migrate your object, if the user don't need objects in the source bucket, so he can also apply delete from source policy. So this is what we have got in migration. So that's all for the use cases. Thank you, Ashit.
Yeah, thanks, Saurav. So these are some of the very common use cases and very well explained by Saurav. And many of our end users are expecting these type of features. So yeah, so now till now we have talked about different projects and their some of the key project features and all. And so we have been evolving. So if you see, we started with some of the release on the left side, you can see the release that was, we started with 0.1.0 and we are now at 1.1.0. So that is the Greenland release. So and with the next release that is named as Hawaii release, we are going to add some cool features and some futuristic things that will go ahead with the H release beyond. So we it follows like A, B, C, D. So next we'll start with I, and there we will have some cool features of edge, data protection and all. So stay tuned for that. Tomorrow we'll be talking more about the upcoming Hawaii release contents, the features that we are providing, as well as some of the futuristic thing that we are delving into. So stay tuned for tomorrow's demo and session by Sanil, Kiran, and demo by Himanshu and Shule. And yeah, so that's pretty much from the release and roadmap. So now we have seen like all the features and all. So all these features, what till now Greenland we have available, we have picked some of the key features, and that is where I'll invite like Sushant and Asif. So Sushant, over to you. You can show us some of the cool features of Soda that we have provided.
Thanks, Ashit. You're able to hear me, right?
Yes, yes, yes.
Okay.